there are four main areas: the ribbon, the workflow panel, the main view, and palettes. The complete version history of 3D models from tools like Revit, Tekla, ArchiCAD, and SketchUp are also dragged and dropped into the view. BIM uses object-to-object clash detection, has some cool auto-reveal features, and an integrated issue management and RFI tracking process. Activating the model processes the geometry, groups similar elements, and calculates quantities. These quantities are not just the typical rudimentary quantity lists. They are, in fact, what we call construction caliber quantities, exactly what the estimators and schedulers require. Patented non-destructive location management then virtually splits model elements floor by floor and for each pore zone. This recalculates the quantities required in each of the project locations. As we move on to using these quantities in our workflow, it's important to note that any historical investment in legacy systems is not lost. We start with many customers simply importing any standard templates or a complete project estimate ready to be developed with model-based data as it becomes available. We could also start from scratch in an Excel look and feel spreadsheet, tabbing between cells and entering data. If we have standard data or assemblies from a previous project, we can just simply drag and drop them into our project. We can now reference these quantities from our consolidated takeoff to complement the cost plan where necessary. The element to quantity to cost integration means that a manual change to the takeoff or an updated model will inform the cost plan automatically. As the cost plan develops and versions are marked, the stoplight colored Cost Explorer tree helps us understand and explain the change. It warns of over budget in red and also suspiciously low numbers shown in blue, and all of the views are filtered just by selecting a node. The next step is to leverage our estimating quantities, costs, and any resource data to load the schedule. We drag and drop the cost line items into scheduled tasks and see how the quantities and productivity data now drives the schedule durations. The location-based quantities drive location-based tasks, which can be manipulated in both the flow line and the Gantt view. We define trade logic, which is automatically copied to all relevant locations, and balance the schedule around the bottleneck trades by simply dragging and dropping the lines. The system will tell us what manpower is required in order to meet the desired pace. The Gantt chart, resource graphs, cash flow, etc. are all kept in sync automatically. The byproduct from the integration is a 4D simulation. As we move into the controlling phase of a project, we monitor progress against the target, review deviations in the flow line view, and automatically forecast the effect of not doing anything differently over the next few weeks. We can test control actions to define the best plan to correct any potential delays. Here we can see clearly that the subcontractor will need 4 crews in order to stay on target. By playing the 4D simulation, we can select the layout points for that week and upload them to the total station for the layout in the field. When the work is installed, the actual in-place points are imported and compared, and any out-of-tolerance points are flagged for investigation. All of the data within BIM can be cut, sliced and diced into tables and charts using an absurdly powerful and completely customizable reporting engine. This report shows graphs and tables highlighting changes between 2 versions of the estimate. Right now, things are changing. Built on an enterprise-class database with best-in-class graphics engine and extremely simple user interface, BIM is the next-generation construction office for our industry. We are now able to complete the data mining loop. The companies that will excel in this knowledge era are true learning organizations. For contractors, it means those that have a system to collect, track, and mine quantities, productivity, and cost. These companies will be leaner organizations and win much more work as a result. This is not vaporware or something that might happen tomorrow. If your company has already understood that there's more to BIM than pretty pictures and clash detection, and if you haven't started already, you should gather your A-team, partner with Vico, and commence your So
So basically, that's what you can do, okay, with BIM informations and to move it into 5D, alright? So, okay, 5D is basically about how you can actually go and manage, okay, your cost structure, alright, whatever that you're going to take, okay, from the information that you get from the model, okay. So the next one is basically with regards to the 6D, okay, which is the facility maintenance, right? However, right, for BIM to move into FM, okay, there are a lot of effort that you need to actually go and, take into consideration for, right? So it's not really that straightforward, okay? So to tell you the truth, right? So if you are in construction, okay, the way that we look into data, even though we look into buildings, all right, it's a little bit different compared to those that actually look for data for facility maintenance, okay? So you need to, be careful about this, right? Okay. So I have another video right here.
Working in construction, it's easy to get caught up in the process of designing, pricing and delivering buildings, and to forget that those buildings are then around for many decades afterwards, having a pretty big influence on how we live our lives and run our businesses. In this video, we're going to look at 6D BIM and the value it can bring. If you're coming into this cold, here's a quick refresh on what BIM itself actually is. Building information modelling is a verb. It refers to the process of creating information models or data sets about built assets formed of graphical and non-graphical information in a shared digital space known as a common data environment. The information builds in richness as the project stages progress until that complete data set is handed over to the client at completion. As you create an information model, you can add scheduling data to different components, generating accurate program data for your project. This is known as 4D BIM. You can then link cost data to various components in the information model to generate estimates, and this process is known as 5D BIM. Taking it one step further and adding information on the expected lifespan and maintenance requirements of a component to support facilities management is what we call 6D BIM. That data can include details about the component's manufacturer, when it was installed, the necessary maintenance that it requires and when, how to operate it at its optimum level to enhance performance or conserve energy, and its expected lifespan. Just as an aside, it's important to note that 6D BIM refers to a particular way of linking data to an information model, an additional dimension, if you like, of data. It's very different to the BIM maturity levels that run from 0 to 3 and beyond, describing the supply chain's ability to exchange information in a digital way. 4D, 5D and 6D considerations can all occur within BIM level 2. If you're working with 6D BIM, it would be wrong to say that you're working at BIM level 6. Once collated and linked into the information model, that 6D data can be used to support decision making during the design process and to support the operation of the built asset once it's in use. Let's take a quick look at both of those applications. Firstly, let's look at how 6D data can support the design and delivery phase of a built asset. At design stage, 6D information enables teams to consider the impact of their proposals over the building's life cycle, simulating their anticipated outcomes and costs. In that all-consuming delivery phase we spoke about at the outset, it helps switch the focus from capital costs onto the whole life operating cost of the asset. The earlier you can do this in a project, the greater the value it will add. Ideally, you do it right from inception. That value is realised in supporting the operation of built assets once they're in use. At handover, the project team will be able to pass this complete data set, now known as an asset information model, over to the building's end user. The digital model provides them with a more controlled, accessible and easily navigable way of managing their information. It's much more practical than the bundles of lever arch folders that are handed over traditionally. We'll take a look at how you can hand over a digital model to an end user in a different video. With data on maintenance, lifespans and energy performance to hand, building operators can determine the costs of these activities and create spend profiles over a building's life, pre-planning maintenance activities years in advance. It helps them adopt a completely planned and proactive approach to facilities management, as opposed to a reactive one, when unexpected events and costs can crop up at any moment. Where maintenance does occur, or where an asset is extended, refurbished or remodelled, operators can update the information model with the relevant points about that event. Having this available is especially powerful when creating similar built assets in the future. It enables design teams to hone proposals accordingly based on real, in-use data. And in construction terms, that's kind of the holy grail. That data will enable us to deliver better buildings and to support numerous other industries that all contribute to our economy and our way of life. That's when people will understand the importance of construction and give it the respect that our industry so badly deserves. If you don't work in construction and just stumbled across this video, you might be stunned to learn that, for the most part, our industry don't really consider the operational phase. They tend to focus on capital costs. And that's largely down to the fact that winning projects is decided on the price of building them, rather than the value they can offer in the long term. If that sounds shocking to you and total madness in the context of what I've just explained in this video, well, you're right. In the UK, PAS 1192 Part 3 covers the process of managing a built asset using BIM. It's a free download from the British Standards website, this link, and we have a short explanatory video about it on the B1M channel.
Right? Okay. So I like the fact that he said that our industry is a mess. Right? We need to admit that. Okay. So like I mentioned earlier, we actually focus on construction. Somehow we forgot that we need to be maintained. We pass it over. All right. I mean, I've never seen an as-built drawings that is very complete. All right. I walked into a 400 million worth of construction and asked for, you know, the as-built drawing. I just open the drawing, I know it's wrong. Because why? Because the columns are all round, and at the lobby the column is all over. All right. So that's the level of information that we share. Okay, pushing through the life cycle of the buildings, right? And shouldn't happen. Okay.
Working.
So that is the, you know, the 3D, 4D, 5D, right? So this is the terminology that you will come across on BIM, right? So the next thing that you will come across normally for BIM project is about the level of maturity, right? So this is talking about the level of organizational readiness, okay, to adopt and execute BIM, right? So now, if you're getting into a BIM process for projects, right, so everybody need to be at least on the same level, all right? You can actually work on CAD, okay? That means that you are on level 0, okay, on BIM, all right? You are just at the bottom of the staircase, all right, to get into BIM, all right? And then we have level 1, where you actually have models, okay? If any organizational start to actually go and work into a model-based, okay, information, does not mean that they are, you know, very, very advanced in the process if they don't do it correctly, all right? Having a model, okay, or having Revit doesn't mean that you are, okay, much more than level 1 if you don't do it correctly, okay? Now, currently in Malaysia, okay, if you are talking to organizations such as Gamuda, UEM, IJM, everybody is talking about BIM level 2, all right? BIM level 2, alright? So what is BIM level 2? BIM level 2 is actually about having a BIM processes that you can actually do, okay, by leveraging on the CDE, which is the Common Data Environment, alright? Now, Common Data Environment requires you to have a system that would actually go and monitor all the information that go in and out, alright? So it doesn't mean that everybody is looking at the same information. It's just that the informations are all related. Okay, and in order to actually go and get to this level 2 CDE, all right, so there would be documents that you need to actually go and refer to, such as PAS 1192, all right, and the holy grail of what we do right now is that trying to get to level 3, all right, which, okay, the UK is actually leading the way. They are actually, setting up standards for this, okay, for BIM level 3. Right? So BIM level 3 is talking about, okay, integrated BIM. So we have a lot of challenges to actually go and get to this, right? Because our infrastructure readiness is not there, okay, and basically the base technology to actually go and push this is not here yet, all right? So that's one of the challenges, okay. Now, if you want to know about this, okay, terminologies and whatnot, okay, you can refer to this, all right? Standards, all right? So you can refer to this BS 1192, all right, British Standard 1192. But this actually is the base for what comes next, okay, which is the PAS 1192, all right. It's a boring document, all right. I'm telling you, right, it's a very boring document, okay. But okay, it explains quite a lot technically about what you need to do, okay, for BIM, how you should name your file, how you should share the file, the limit of liability of project files, okay, and things like that, all right. So, okay, and the other thing is that, okay, I think you've heard about LOD. Have you heard about it? Level of details. or level of development of models. Have you heard about it when you work on BIM? Okay, I heard differently from Ms. Go, alright? So, now, there is this thing about, okay, how much information is enough? Or how much information is not enough, alright, for you to do your work, okay, in BIM? Alright, so this is where we start to actually have this thing called LOD, alright? So LOD stands for level of development or level of details, alright? And it basically discusses about, okay, the amount of information that you need to have, okay, in your documents. Your documents is your digital data, alright? It could be your printed data, that's also document, alright? Now, there are quite a number of LOD standards, alright? But the most referred to is actually LOD by the AIA, alright, American Institute of Architects, alright, and you can actually go and download this. They update this every year. I think the latest one is the one that they published last year, September. Okay, LOD specification for 2017. Okay, but LOD is not new, alright. For building industry before this, okay, we actually have this. Okay, it is actually coming from this thing called uniformat, alright. Okay. This is for US and Canada, or for us, we are more into this thing called Uniclass. Alright, okay, that is the kind of classifications that the British are using. Alright, okay. Now let's talk about LOD. Alright, so what is LOD? Alright, so LOD is basically with regards to informations that you get from the data that you have. Alright, so LOD 100, okay, if you are referring to a mechanical system, alright, so let's say that this is a mechanical item, alright, so you need to actually go and specify, okay, only the system item, alright, so symbolically represented, alright, so at LOD 100, that means that is very basic information, alright, and then you get to the LOD 200. So for LOD 200, you start to actually have a lot more information, alright, and you might also include, okay, some non-graphical data, alright. LOD 300, okay, the geometric information becomes a lot clearer, alright, and this is to show, okay, mostly design intent, okay, that the full design intent of the designer, what they wanted to do. Alright. Now, if you are a consultant, that means that if you are an architect, structural engineer, or mechanical engineer, you would not work beyond LOD 300. Okay. Alright. Because once you actually go and get deeper into construction, this is where we start to look into LOD 400. LOD 400 means that information as per what is constructed on site, what you're going to construct. This is shop drawing levels. Alright. I'm not sure how much you are aware about the relationship between consultants and the contractor. Alright? But I can tell you this, alright? Consultant have intent. Contractor make it real. Alright? So they are the one that is going to go and select this item and put it. Because they want to put this item and place it, they need to know what goes into placing those elements. Alright? Okay? So they have a lot more details compared to the consultant. Alright? So if you talk to architects, they don't care how, the consultants are going to hang this ceiling. What they know is that I need the ceiling height to be 2.7 meters. That's what they need. So the architect is not going to give you the ceiling hanger. That's the contractor's work. Alright, okay. Now, the last one is basically validation for facility maintenance to bring it into the 6D. So this is where the LOD 500 comes in. Alright. Now, LOD 400 still talk about what you plan to do on the construction. Okay. So all these are virtual basically. LOD 500 is really talking about validation of what you have built on site into the virtual information. Alright? So that means that If you have a door, the door is really there on site. Because what happens right now is that there are a lot of work that is done virtually, but doesn't really relate to what happens on site. Okay, so I can bet a very high amount of ringgit to say that you can get any drawings, any blueprint of a building, alright, even for this building, look at it, and I can guarantee you, most of the items are not where it is on the drawing compared to the real one. Alright, because there is no actual validation. Alright, I mean, our as-built drawing is abysmal. Alright, okay. So this is another example for architectural item. Alright, so this, in terms of model, looks very complete, right? LOD 100, very nice. But that is very, very highly representative only, right? Because you want to design an office, so you need to put in office chair, but it's not exactly the type that you might end up using, alright? So when you talk about LOD, right? So one thing that you need to understand is that it's not only about the details that you put into the model. It is also about metadata, like this one. So the detail of the models is actually getting, it could be getting more and more, but besides that, you also put in a lot more information, this metadata. Put it this way, alright? Somebody give you photos, alright? You can look at the photo, would you trust 100% the photos? Let's say your boyfriend or girlfriend, you want to check where they are. But they send you photos. Would you just look at the photo, or can you look at other clues? Alright? So you can look at the metadata. For example, when the photo is taken, from the photo you can check which camera is being used for, what date it was taken. Alright? That's what this is. LOD is not just about the photo, but also about the information that comes with that photo. Alright? So when you discuss about LOD, alright, the model might not be, getting more beautiful as you go from one LOD to another, but the informations are getting more and more. Alright? So that could be the case with LOD. Alright? So another example is this. Alright? So this is the stages, alright? Concept, plan, design, construct, and operate. And the other thing is basically we are talking about structural elements, alright? So LOD 100 for structural engineer is basically for them to tell, I'm going to use this steel brace frame. That's it. So if you want to calculate, you just go and calculate a ballpark figure, alright? And then LOD 200, you have a generic placeholder, you have column and beam, alright, or slab or whatever, right? LOD 300, then you have a specific assembly, roughly the size, but your structural engineer is not going to give you very detailed. LOD 400 is already what your fabricator is going to give, alright, because they are going to actually go and tell you exactly how it's going to be cut, how many bolts that they're going to put in, alright. So that is the LOD, some other LOD sample, alright. I think the next one is looking at the BIM implementation, alright. So when you look into a BIM component, alright, so you need to look into 3 items: people, process, and technology. But more importantly is that organization must have good policy to support this, alright. So case in point is this, alright, for the adoption of BIM, alright, in JKR, I've worked with them, I've consulted them about their adoption, alright. So one of the challenges is this, government servant would not stay long in one position. There's a reason for that, which I would not want to discuss, alright. But they would not stay long in that position, alright. But for them to adopt BIM, they cannot do that. They cannot have somebody that comes in 2 years and then go, alright, because they need to actually make sure that it is continuous, alright. Now, what happens is that we go to the policy level and advise them that, So what they did was they actually created the specialized BIM department. They have it, all right. It's actually in Manara PJD in KL, level 27. You can go and visit them, all right. So in there they have all the engineers, all right, all the managers, all right. And okay, what they do is that they change the policy slightly. They allow these people to stick longer. That's why they can actually go and develop, okay, whatever that they wanted to do with BIM. All right. Now we know about technology. If you want to adopt technology, means that you look for the software and the hardware. Okay. But most people, okay, also understand the people part. That means that you have the software and hardware. What you do next is basically you go for training, correct? Okay, all right. But most organizations fail at the process side. Okay, process is something that you cannot simulate in a training room. All right. So like you come to the university, right? You learn, right? It wouldn't tell you anything about what happens when you start to work. All right. You might have an idea. Even if you are an intern, you go into an office, it's not the actual experience. Right? What I'm saying is that this is where most organizations fail. They did not look into the process part. Okay, the process part is very critical. All right. So so in the workflow for BIM, all right, so we can actually look into from plan, design, construct, and operate. Okay, what is important for any BIM project is for the project owner to come out with this EIR, Employer Information Requirement. Okay, now I think when you learn about BIM, okay, one of the things that you might heard a lot is this thing called BIM PEP, Project Execution Plan. All right, so the project execution plan that you have for any BIM based project processes must be based on the EIR. Alright, so EIR comes from the project owner. So it will actually have three components: technical, management, and commercial. Alright, so technical is talking about what software platform that you're going to use. I have done this before where we actually have problems. Everybody say that, oh, for this project everybody is going to use Revit, but everybody comes with different version of Revit. So nobody get anything done. Alright, so that's the problem. So that's why the BIM PEP would need to, the EIR need to actually go and make the whoever that is coming into that project look into that. Alright, and then the management part. Okay, so there are a lot of requests. Okay, oh, this project owner wanted this BIM the full BIM process. Okay, but the thing is that there is no reference to any form of standards and whatnot. Okay, so that is also a challenge. Alright, and the last part is basically on the commercial. Alright, so what are the deliverables that you're going to do, alright, and things like that. Okay, so I have experience when I was working with Sam Dabi. Alright, so I was the BIM technologist there. So when we were there, we put in requirement for BIM project. Okay, so the mechanical engineer said yes, we can do it. Alright, no problem. Okay, we go and do. So they do everything, but they did not submit. They just show it. Alright, because they say that if you want this data, you need to pay me 800,000 for all the data that I've created, because the EIR is not clear about deliverables. We fail in that part. Okay, that's why when we actually start another project, then we actually go and change the TOR, term of references, that built into the contract. Okay, so that we can tackle the project deliverables. Okay, so these are some of the EIR, not a very good one. Okay, we see this a lot in the project requirement. Sometimes it's just one clause like that, clause number 7. That is my BIM requirement. Opens cans of worm. Right, I don't know what it is. All right, but there are also good ones. All right, like this one that have a lot of clarity in terms of the EIR. All right. Okay. So what you do is basically the project owner will give you the EIR. All right. And basically the consultant will start to actually give you the. What the consultant should do is give back a BEP, BIM execution plan. All right. Okay, so for BIM execution plan, what you can do is that you can refer to some, predefined templates. All right, so this is quite popular. All right.